Hello and thank you for clicking on this video. Today we will be examining the black hole Sagittarius A** black hole located at the center of our Milky Way galaxy and how it could unveil revolutionary new science, especially if we move beyond conventional black hole models that are increasingly challenged by the strange recent data. Sources are located in the description. If you enjoyed, please remember to like and subscribe. For centuries, black holes have confounded astronomers and physicists alike. These enigmatic regions of spacetime exert gravitational forces so extreme that nothing, no particles or even photons, can escape once trapped past their boundary. Yet we have never directly glimpsed a black hole's border or peeked past its veil to what exotic realms might lie within. A black hole is a cosmic entity whose gravitational pull is so phenomenally powerful due to its sheer mass occupying an extraordinarily minute volume that it can effectively trap anything that ventures too close to it. The critical perimeter delineating the threshold beyond which escape becomes impossible is called the event horizon. Even light speed is insufficient to overcome the gravitational grasp of a black hole beyond this definitive horizon. Sagittarius A is a highly compact radio source situated at the very center of our Milky Way galaxy. First pinpointed in early radio maps of the galactic core, its location precisely coincides with the gravitational center traced by orbital motions of interstellar matter. The extreme compactness yet prodigious emitted energy fluxes from Sagittarius A immediately spurred speculation that a supermassive black hole must account for these exceptional characteristics. Decades later, circumstantial observational evidence has only solidified the notion that several million solar masses are trapped inside Sagittarius A. Its mass, estimated from stellar dynamics, far outweighs its limited spatial scope of under 25 billion kilometers wide. The coupled enormous overall mass and extraordinarily minute size of Sagittarius A** strongly points to it harboring an invisible, supermassive object best matching the description of a theoretical black hole. Yet the object at the heart of our galaxy retains its enigmatic secrets, with observations that continue to baffle astrophysicists who study it. Unraveling the genuine identity of the alleged monster in Sagittarius will profoundly reshape understanding of cosmic phenomena. Alternate explanations invoking dense clusters of dark objects like neutron stars or stellar mass black holes fail to reconcile all constraints. Mainstream theory now strongly favors a single supermassive entity to explain Sagittarius A's perplexing nature. Yet confoundingly, recent multi-wavelength observations including of magnetized plasma filaments, short timescale infrared flares, and periodic X-ray brightening have no easy interpretation even in a standard black hole context. Some emissions hint at source trajectories or cycling processes occurring well within the calculated photon orbit boundary. Either our basic dynamical grasp falters, or stranger realities reside at the Milky Way's heart than textbook black holes allow. As the enigma compounds with further data, Sagittarius A** promises to profoundly impact understanding on cosmic scales. Supermassive black hole candidates like the one thought to occupy the heart of our Milky Way galaxy in Sagittarius A** provide the best opportunities to probe the ultimate natures of these gravitational prisons. However, increasingly perplexing observations emanating from the vicinity of Sagittarius are challenging long-held assumptions about black holes. Powerful outflows, wayward trajectories, and emissions with no accountable origin now spur questions over what truly festers at the center of our galaxy. Unraveling the black hole mysteries of Sagittarius A**. Mainstream science firmly theorizes that Sagittarius A must contain a supermassive black hole like those suspected to inhabit most galactic centers. This standard model provides a surprisingly successful explanatory framework for an immense cosmic object confined within an unusually compact region. Yet as mounting observations push the envelope of accountability, the plot continues to curdle surrounding this reputed beast lurking 26,000 light-years away. The following essay chronicles a series of vexing observations that fail to align with simplistic notions of black holes. From conjectures over trans-relativistic influences to glimpses of entirely unpredicted phenomena, the emanations from Sagittarius A continue to mystify astrophysicists. We have only brushed the furthest fringes of the unseen colossus at the Milky Way's nucleus. What realities exist behind the black hole charade? Daring intuition must guide us onward to illuminate secrets that skulk in Sagittarius constellation, written between the stars. The conventional black hole paradigm. According to dominant physics theories, a black hole is a region of spacetime exhibiting gravitational accelerations so intense that nothing including particles and electromagnetic radiation can escape from inside the event horizon once trapped. The boundary delineating the point of no return is known as the Schwarzschild radius. Its size is directly proportional to the black hole's mass. Beyond theorization, astronomers have assembled growing observational evidence over decades that supermassive black holes likely reside at the centers of most large galaxies. Our Milky Way's central black hole candidate, Sagittarius A*, is estimated to have a mass equivalent to over 4 million suns confined within a sphere less than 21 billion kilometers across. The extreme warping of space-time imposed by the tremendous mass density prevents direct visualizations of a black hole's internal structure. Any light or matter sent to probe the depths never returns. Yet from the observable gravitational consequences, the Standard Model presumes that infinitesimal dark core of infinite or indeterminate density acts as the ultimate repository for all matter and energy drawn into its abyssal grasp. Perplexingly, whether time or universal physical laws operate at all inside the theoretic singularity remains conjectural since all known models break down mathematically. While dominant gravity theory can accurately predict outside behavior, the true interior workings of black holes may conceal shocking revelations about nature's deepest truths. The accepted framework also cannot yet adequately explain recent Sagittarius A* observations showing magnetized plasma filaments tracing back to a centralized origin point, or the 74-minute cyclic X-ray flares that exceed expected time dilation scales. The mainstream black hole paradigm strains more each day under the heap of disconcerting phenomena lacking comprehensive interpretation. While plenty bend theories to patch fit each new incongruity, perhaps we must expand the underpinnings themselves to encompass expansive unseen realities. Just as general relativity supplanted Newton by addressing previously unexplainable orbital discrepancies, a fuller gravitation theory may now await formulation. The current model leaves too many doors beyond event horizons unturned. What lies in the vastness behind him is ripe for pioneering exploration using intuitive inquiry as our lantern through the abyssal unknown. The truth invariably proves far stranger than all antecedent fiction. As exceptional new observations accumulate from Sagittarius A*, we must recalibrate mental boundaries on what constitutes the plausible. While extreme, even the conviction of entirely unknown worlds or billions of other universes somehow tucked inside black holes no longer seems so preposterous nor detached from empirical motive. A vastly more intricate cosmos likely awaits beyond the veil. The mysteries of Sagittarius A*. There are a few key things about the recent observations of SG A* and its surrounding environment that are perplexing or unexplained by current physics theories. 1. Magnetized plasma filaments spanning hundreds of light-years appear to trace back to SG A* in an organized bidirectional pattern perpendicular to the plane of the Milky Way. The source of these vast and remarkably well-collimated outflows emerging from a central compact region defies explanation. 2. An distinct population of short filaments aligned parallel with the galactic plane also orient in a nearly radial convergence toward SG A. These filaments may imply unseen flows of matter spreading along this plane, compounding questions of what mechanisms can generate two drastically different outflows from SG A's immediate vicinity. 3. Regular flares of X-ray emissions emanate from the direct region of SG A* on a periodic cycle of about 74 minutes. To modulate this clockwork variability, theoretical models have been proposed involving a small orbiting body or hotspot dynamics around the black hole candidate. However, the exceptionally tiny diameter calculated for such an orbit lies deep within the gravitational stranding zone of the point of no return, where even photons should be forever trapped by relativity. In summary, two perplexing categories of magnetized filaments bookending SG, i.e. asterisk in perpendicular orientations, raise questions over the necessary power source and collimation factors. Meanwhile, the cyclic X-ray brightening traced to near the event horizon itself does not abide by standard spacetime warping concepts. Rather than reconciliations, accumulating SG, i.e. asterisk observations increasingly strain and stretch contemporary theory. New physics may soon be required to account for our galaxy's core riddles lurking a mere 26,000 light-years away. Sagittarius A** SG, I**, is an extremely compact radio source at the center of our Milky Way galaxy. For decades, it has been hypothesized to contain a supermassive black hole with a mass of over 4 million times that of our Sun. This black hole candidate alone cannot explain some intriguing phenomena that have recently been observed in its vicinity. Outflow tracing filaments near Sagittarius A**. SG, Ra* is surrounded by long magnetized filaments emitting synchrotron radiation. The orientation of these cosmic filaments indicates powerful bidirectional outflows emerging roughly perpendicular from the galaxy's equatorial plane. These vast and remarkably well collimated particle jets span hundreds of parsecs in opposite directions from SG, Ra*. In addition, an entirely distinct population of short filaments has been detected with radio telescopes. Unlike the longer filaments, these small filaments have position angles closely aligned with the galaxy's own plane. Their orientation points back to SG, Ra** itself in an almost radial pattern, hinting at an unseen flow of matter spreading along the galactic plane. The mechanisms generating two drastically different outflows from the same compact region remain unknown. Puzzling periodic flares from Sagittarius A**. Adding to the mystery, regular flares of X-ray emission have been observed originating from the vicinity of SG, Ia. These large flares recur with a cycle of approximately 74 minutes. One hypothesis to explain this periodicity suggests that a small orbiting body around the black hole candidate may be modulating the flare emissions each time it completes an orbit. However, the deduced orbit lies far deeper in the gravitational well than what is normally considered possible without falling beyond an event horizon. Mainstream black hole models cannot account for such behavior, seeking definitive answers through further observations. While provocative, these phenomena ultimately raise more questions than provide answers about the true nature of SG, Ia. Crucially, the observations must be verified over longer time baselines to gather robust statistics on variability patterns and periodicities. Additional data at radio, infrared, and X-ray wavelengths can also help discriminate between theoretical models. As an example, optical spectroscopy can determine whether expanding clouds of ionized gas support the scenario of matter outflows from SG, Ia. Likewise, infrared imaging may reveal signatures of accretion and emission interactions on sub-arc-second scales near the black hole candidate. The key is systematically testing observable predictions from different hypotheses that could potentially explain the unusual filament orientation patterns and periodic flares. With rigorous analysis of new multi-wavelength data, we can hope to definitively unravel the mysteries that continue to challenge understanding at the heart of our galaxy. Confronting paradigm-changing possibilities. While mainstream astronomers consider SGRA* to definitively contain a black hole, its atypical environment warrants reasonable skepticism. The observed phenomena stretch the conventional framework of black hole theory to its breaking point. We must avoid inherent biases and confront the possibility that exotic new physics may be unveiling itself through these galactic center observations. Rather than hasty extrapolations of known science, the correct path forward is to first gather more empirical evidence. Only once a comprehensive catalogue of observational constraints has been assembled can we discriminatorily evaluate radically different interpretations. A presumption either for or against the standard black hole paradigm is unwarranted without thoroughly testing alternate proposals. The symbols of magnetized filaments, puzzling periodic flares, and other contextual clues paint a tapestry filled with tension. While the full image has yet to emerge, what has already transpired at the heart of our galaxy may force revolutionary shifts in our cosmological perspectives. The only closure thus far is that no satisfactory explanation exists for the occurrence of these phenomena around Sagittarius A. The shroud masking its true identity has only tightened, awaiting definitive pierced by further revelations.